In this video, I will show you how to graph and label conic sections like circles, ellipses, parabolas, and hyperbolas. Let's take a look at problem number 1. This is clearly a circle, and when you're looking at the standard form equation of a circle, the center is going to be the opposite of these two. So this is going to be -2, +4. Let's go ahead and graph that. -2, +4. Here's the center of the circle. This number is the radius squared. So if the radius squared equals 16, that means that the radius is 4. That tells me that if I go 4 in all directions, I should be on the circle. So if I go 4 to the right, 4 up, 4 to the left, and 4 down, these should all be points on the circle. So that is enough for me to be able to draw the circle. All right, and I think that's it for problem number 1. Let's move on to problem number 2. This is a parabola. I can tell because I have one variable squared. Now, in the standard form of a parabola, I can get the vertex by doing the opposite of these two numbers. But be careful. This is sort of backwards. The x-coordinate of the vertex has to come from the x part of the equation. So that's why I will have the 3. And then the y-coordinate will come from the y part of the equation. So the opposite here will be -2. So there's my vertex, 3, -2. So let's graph that vertex. Actually, I'm going to do my vertex in red. At a glance, we should know whether the parabola is facing up, down, left, or right. When the y part is squared, we are looking at a sideways parabola, so either left or right. When this number right here is negative, that means it will be to the left. So we're looking for a parabola like this. Now, there's something called the focus that is in the interior of the parabola. And then in the opposite direction, there is a line called the directrix. So this is like a thumbnail sketch of what we're shooting for. All right, so we have the vertex, okay, which is this point right here. In order to find the focus, we need to know what the p value is. Well, this number right here is 4p. In other words, 4p is equal to -10. If I divide both sides by 4, that's going to give me p is equal to -5/2. As a decimal, that would be -2.5. Okay, so the p value tells us where the focus is going to go. So if I start at the vertex, I know my focus will be to the left of this. The p value tells me how far to the left to go. So I will have to go -2.5 to the left. Okay, so my focus is going to be right here. Oh yeah, so the directrix should be in the opposite direction, the same amount. So if I go to the right 2.5, then my directrix should be right here. So draw that as a dotted line. I need 2 more points in order to graph this parabola. For that, we will use the focal width. See this -10 again? Because of that, the focal width is 10. It's always positive. So since the focal width is 10, that means the width of the parabola at the focus is 10, which means if I go up 5 and down 5, that will give me a total focal width of 10. So that's enough information for me to be able to sketch this parabola. All right, now let's label the rest of these points. So the focus here is the point 1/2, comma, -2. The directrix is, see, this is 4, 5, so this is 5.5. But it's a vertical line. Vertical lines always have the equation x equals something. So this is x equals 5.5. And I think that's it. That's all that they asked us to do for problem number 2. All right, this is problem number 3. And this is the standard form for an ellipse. So in standard form, the center of the ellipse will be the opposite of these two. All right, it doesn't look like they actually asked me for the center, but I need it anyway, so I'm just going to write it down. So the center is the point 1, -4 because of these two things. So let's go ahead and graph that. 1, -4 is right here. So this is going to be the center of my ellipse. So next we're going to find the vertices. For that we're going to need the a value. Well, the bigger denominator is always called a squared. And if a squared is equal to 64, that means a must equal 8. Since the 64 is with the x term, I'm going to do plus and minus 8 in the x direction. So going back to the center, I'm going to go 8 to the right, and I'm going to go 8 to the left. Okay, so these will be the vertices of my ellipse. So that's -7, -4. And 9, -4. All right, now let's find the co-vertices. Well, I need the b value for that. B squared is going to be the smaller denominator. So that means b is equal to 4. Because the 16 is with the y term, I will do plus and minus 4 in the y direction. So if I come back to the center, if I go up 4 and down 4, these are my co-vertices. So that's 1, -8, and 1, 0. So those are my co-vertices. Next I need the foci. To find the foci, I'm going to need the c value. So we need to remember that, let me switch to green. For an ellipse, c squared is always equal to a squared minus b squared. So that means c squared is going to equal 64 minus 16. So that's c squared equals 48, which means that c is equal to the square root of 48. 48 is 16 times 3, which means that c is equal to 4 radical 3. So I'm going to use this to help me find the foci. But first, I could use a decimal approximation. C is approximately 6.9. Okay, the foci always go in the same direction as the vertices. They always go the long way. So let's see, 2, 4, 6, 6.9 should be about here. And if I go 6.9 to the left, that's going to be about here. Might as well go ahead and draw the ellipse while I'm at it. Now, I cannot label the foci using this decimal of 6.9 in any way. Instead, I have to use the 4 radical 3. So what you want to do is first decide the value that is easy to know. The y value of these points is very clear. All of these points have a y value of -4. They're sitting right on the line at -4. So since the y values are -4, I can definitely put something comma -4 and something comma -4. Get those y values out of the way. Now I just have to worry about the x values. All right, because it's a decimal, it's in between the lines, it's more tricky. What you want to do is start with the center. What is the x value of the center? Well, hopefully you can see that the center has an x value of 1. It's 1 to the right. So we're going to start with that. So I'm going to put a 1 here and a 1 here as a starting place. So if I start at 1, to get to this focus, I'm moving to the left. Or you could think of it as subtracting a certain amount. Well, guess what? I'm subtracting 6.9. I'm subtracting 4 radical 3. So I started at 1, and I'm going to the left, so I'm subtracting 4 radical 3. So the x-coordinate then is 1 minus 4 radical 3. Similarly, the other focus, I could think of it as starting at an x value of 1 and going to the right by 4 radical 3. So I'm adding 4 radical 3. So therefore 1 plus 4 radical 3 will be the x-coordinate of that focus. Now the eccentricity is always the c value over the a value. Okay, so the c value was 4 radical 3, and the a value is 8. So we're going to have 4 radical 3 over 8. 4 divides into 8 evenly, so this is going to wind up being radical 3 over 2. You must reduce. So that should be it for problem number 3. All right, and there we got a nice graph out of it as well. For number 4, we are given the standard form equation of a hyperbola. I know this is a hyperbola because it has the minus sign in the middle. So the center of the hyperbola is going to be opposite of these two numbers. I just have to be careful about the order. So the center is going to be -3, 2. Notice how I had to reverse the order that they're written because the x-coordinate of the center has to come from the x part of the equation, and the y-coordinate of the center has to come from the y part of the equation. So -3, 2, the center is right here. Next, let's find the vertices of the hyperbola. Now, when we are dealing with ellipses, the vertices always come from the bigger number. That's not how hyperbolas work. For hyperbolas, the vertices always come from the denominator of the positive term, which should be in the front. So even though 9 is smaller than 25, this 9 will lead me to the vertices, and therefore I will call it a squared. So if a squared is 9, that means that a is equal to 3. This 3 will lead me to the vertices. Because the 9 is with the y term, I will do plus and minus 3 in the y direction. So starting at the center, I will go up 3, and I will go down 3. These are the vertices, which means I'm dealing with a hyperbola that's going to be like this. All right, I'll have to be much more precise than that, but understand that this is a vertical hyperbola. I also know that because the y term is first. So that's always going to be a vertical hyperbola. Let's go ahead and find the co-vertices. The denominator of the negative term will always be b squared. If b squared is 25, then b is 5. Because the 25 is with the x term, I will do plus and minus 5 in the x direction. So starting from the center, if I go 5 to the right and 5 to the left, these are my co-vertices. Okay, I guess I'm supposed to be labeling these things. So, all right, my left co-vertex is negative 8, comma 2. Okay, my right co-vertex is 2, comma 2. All right, my vertices are negative 3, comma negative 1. And negative 3, comma 5. So I got my vertices and my co-vertices. I'm going to go ahead and draw the asymptotes now. There's a rectangle that passes through the vertices and co-vertices. You should draw that rectangle using a dotted line, like this. This rectangle will reveal the asymptotes of the hyperbola. Because the asymptotes of the hyperbola pass through the diagonals of this rectangle. Okay, so I'm going to draw a dotted line going through the diagonals of this rectangle. So that's an asymptote. And that is also an asymptote. I could go ahead and sketch the hyperbola right now, because remember, these are the vertices, so my branches must be here. All right, so I need to draw my branch, and I need to draw it approaching the asymptote. On both sides, approaching the asymptote. Okay, so there is my hyperbola. All right, since I just did the asymptotes, I feel like I should go ahead and say the equation of the asymptotes now. The equation of the asymptotes will always be like this. Y minus k is equal to plus or minus m times x minus h. Okay, the y minus k and the x minus h, they are the same things that are in these parentheses right here. So that makes it really easy if you've got standard form. So the y minus k is the y minus 2 that you see right here. Uh-oh, technical difficulties. No! Yeah, I definitely just had to do this entire problem over again. Anyway, so the h and the k are just the center of the hyperbola. This is the point slope form of a linear equation. So m is the slope, and I'm simply using the center as the point. Now, the slope, we're just talking about good old rise over run. So for example, if you look at this diagonal right here, from the center out to this corner, what's the rise and what's the run? Okay, because that's going to give me the slope. So hopefully you can see that this is up 3 and over 5, which is really the a value and the b value. So that's it. That's the slope. For the lower equation, the slope is negative 3 over 5 because it's down 3 and right 5. So put those together and you have plus or minus 3 over 5. So that's it for the asymptotes. For the foci, we will need the c value. So remember that for a hyperbola, c squared is equal to a squared plus b squared. For an ellipse, this was minus. So these are sort of opposites. For the equation that has a minus in it, this is a plus. For the equation that has a plus in it, this is a minus. Anyway, c squared will equal 9 plus 25, because that's a squared plus b squared. Okay, so that's going to be 34. So c is equal to the square root of 34. A decimal approximation would be useful, and this is approximately 5.8. So I can use this for graphing, but I can't use it to label. So 5.8. All right, of course the foci will be here in the interior of each branch. So if I go 5.8 from the center, so there's 3, 4, 5, 5.8 would be about here. And if I go down, there's 3, 4, 5, 5.8 away would be about here. Now to label these, let's start with the x-coordinate because that's obvious. All of these x values are negative 3. So I know I'm going to have negative 3 comma something and negative 3 comma something. All I need is the y value. All right, so that's going to be tricky, but think of it as starting at the center. The y value of the center is 2. So we're going to start with 2. And if we go down, we're going to subtract. Okay, so I'm subtracting the c value, subtracting radical 34. So this will be 2 minus radical 34. And similarly, the upper one will be 2 plus radical 34 because I'm starting at 2 and I'm going up radical 34. So that's going to be it for problem number 4. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.